Number 38 is basically a harder version of number 37. But the principle is the same. If you watch that video, we just followed instructions, and we're gonna kind of do the same thing here. It's just there's more instructions. So the most important thing is to ground ourselves in the most simple instruction, which is almost always just going to be the formula that they give us. So this n equals RT. We're definitely going to use this. So n equals R, flipping around some of the capitals here. N equals RT. And just like for 37, the units are going to be very helpful for us because it keeps us aware of where the numbers are supposed to go. So if we look at this, blah, 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 there's a new store. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store, and each of them stays for an average of 12 minutes. So the 12 minutes is pretty straightforward, okay? That matches with, so average stays for an average of 12 minutes, each stays in the store for an average time of t minutes. That's just their way of saying that this 12 corresponds to the letter T. So let's just pop that in. Boom. This other piece is more of a pain because it's 90 shoppers per hour enter the store, and we do have in the formula the average number of people in the store. Oops, sorry. N. Oops, sorry. Nope. This is why you read instructions. I almost highlighted the wrong thing. They enter the store at a rate of R shoppers per minute. So we have a problem. The units here are telling us what letter we need, but they're also telling us that the data that they gave us is wrong, or it's at least not useful as is. That's shoppers per hour. We need shoppers per minute entering the store. So we can convert this. So 90 per hour, so 90 shoppers per hour. Well, an hour is 60 minutes. So let's just divide, right? And we have a calculator, so 90 divided by 60. You might be able to do that in your head, but that is 1.5 shoppers per minute. And that is the value of R. So we're going to put that in. And now we can solve for N. And, you know, this is following instruction 2, right? If we have a formula and we have 2 of the 3 pieces of that formula, like it's kind of an implied instruction that we should probably solve for the third. So let's just multiply. 1.5 times 12 is 18. Okay. So that's the new store. But they're asking for more from us, right? They're saying the average number of shoppers in the new store at any time is what % less than the average number of shoppers in the original store. Now, luckily, the original store, they do all the work for us. They explain it in the second paragraph. So the N value for them is 45, right? So 3 shoppers per minute entered. That's your R value. So this is R. They're in the store for an average of 15 minutes. That's T. So 3 times 15 got us the N value of 45. So cool. That's helpful. They did it. We didn't have to do the conversion. But now we have another challenging piece, which is dealing with percentages. And on the SAT, I've said this many times in videos for this exam and for previous exams, the percentages in the SAT are hard. And here it's especially hard because we have % less than. So my advice is to find a system that is consistent because the SAT loves to just twist percentages up. So the system that I've come up with is what I call the open formula. Okay, I made it up. It's in my study guides, but it is useful specifically for the SAT. And the formula, I say this on every video where I use it, comes down to the original value times the percentage. And when we have % change, like this one, % less than, we use 1 plus or minus the percentage, okay, to represent the change. E stands for equals and N stands for new. And in this case, original and new, those are just the names I chose for the formula, but it actually works really well here because we have the original store where N is 45 and the new store where the N is 18. So it fits in very nicely with my expectations. And for the P part, we're going to want to be 1 minus P because it's % less than. And this is the advantage of my open formula, is it's intuitive with how the wording of these questions is going to be. So if they say % less than or a % decrease, we're going to see that reflected pretty much perfectly in the formula with a minus sign. If they said percent increase or percent greater than, percent more than, that's going to be represented with a plus sign, as we would expect. So there's a benefit here in that the things go where we would expect them to go if we understand the formula. Percentages a lot of time have a little bit of weird, we need to adjust for the situation, but I don't want to have to do that. Here the situation is pretty straightforward. And so in order to solve for P, we're going to need to move the 45 over. So we do 18 divided by 45, and that is 0.4. And this is where people normally mess up, because that represents 40%, but that's not the answer. 18 is 40% of 45. But if we continue to solve this question and subtract the 1 and drop the negative, we're going to get that P is equal to 0.6, 60%. So actually, let me be very clear, that's not the answer. The answer is 60. Because 0.6 is the percentage, but we always think of percentages written as a decimal when we use them in equations. But when we talk about them, we think of them as numbers basically out of 100. So 60 is what we want to bubble here. It's confusing, and that's the thing, is even if we sorted through all the instructions correctly with the formula, we still have to confront the percentage, which is easy to mess up. And that can be really frustrating if you did all the other work and then messed up on the percentage. So that's why, having a good formula for percentages is helpful. And then also being able to just have the confidence to sort through all this stuff using the formulas that they give you and just kind of knowing they're going to give you all the information you need. I will say one last thing about this question. You're at the end of the test. You may have skipped some other questions along the way. And so you have to be a good judge of yourself. This is confusing, and percentages make it even more confusing. So if you came to this question and were like, I've got 2 minutes left, you might make a decision to just bubble something random, pick your favorite percentage, and then go back to something else where you think you have a better shot of getting the points. If you're running out of time on the math sections, those are the kinds of decisions you want to start thinking about and making, because this 10 points is not any better than another 10 points that you could get somewhere else. They're all the same. All the questions are worth the same. So you want to put your time where you have the best shot of actually solving the question and getting it right. Just something to think about if you're having trouble. This is a good one to skip.